In this part, we'll continue the exploration of the AOVs module. An important concept we need to cover is that by default, available AOVs work on a global scale. In other words, they collect and display data from all surface shaders throughout the composition. But what if, for example, I want to generate an isolated set of AOVs for a specific surface like this concrete material here? The answer to this question lies within the options of the standard shader set to drive the beauty port. As long as these strings and the default AOV names match, the concrete material will be part of the global solution. If, however, they are no longer in sync, the engine will refer to them as custom AOVs, which is exactly what we need. So let's introduce a minor change like adding _concrete to direct diffuse. Now if I navigate back to the display dropdown, it will become evident that the concrete environment is no longer part of the global direct diffuse AOV. The question that stands now is how to preview the path we just defined. What we need to do is set a custom AOV with name matching the one we entered in the concrete material. This can be approached in a couple of ways. Obviously, you can utilize an rnode AOV and manually set it up as described in previous lessons. The recommended workflow, however, is to go through the setup manager. Here we need to click Add Custom AOV, set a matching name, and select an appropriate data type. The default RGBA seems like the most logical option for representing a diffuse path. Once created, the AOV will be automatically assigned to the active list. Pressing OK is the final step, which will add the respective AOV to the Objects Manager, thus making it available in the display dropdown. Now, as you can see, the direct diffuse rays are split in two separate AOVs. One referencing the concrete environment and another one representing the rest of the scene. The true power of the AOV system is based on the fact that it allows us to capture the output of any node as a custom AOV. However, unlike most of the surface shaders, which, as we already saw, utilize a dedicated AOV channel, the rest of the nodes do not have this functionality built in. Fortunately, there is a special group of AOV shaders designed for this particular purpose. As you can see, we have read and write nodes which can handle different data types. The current network is driving the shading of the teacups. So let's say, for example, we need the color bands available as an additional AOV, which we can later take advantage of in post-production. This, as you may have already guessed, requires an AOV write that is able to handle color data. What we need to do next is connect the desired shader to the input port and give the AOV a custom name. Finally, channel the main surface shader in pass-through and connect the output to the beauty port. Now that the path is defined, we need to set up the actual AOV object. The workflow should be familiar by now. Click Add Custom AOV and set matching name and data type to the ones we just defined in the right node. Confirm and preview the custom path from the display dropdown of the IPR. Writing AOVs becomes a bit more interesting if the job requires more than one custom path within the same shading network. So let's drag another write RGB in, but this time use it to capture the text elements visible on the teacups. Connect the respective shader to the input port, assign a custom name, and once again connect the standard shader to the pass-through parameter. Open up the Settings Manager and quickly organize the required AOV object. Back in the shading network, the problem we're facing now is that the beauty port cannot accept more than one input. In other words, with the current setup, one of the custom AOVs will be simply ignored. Similarly to using layer color to combine shaders together, our node comes with a convenient pass-through node, which is able to evaluate multiple AOVs at once. So drag it in, connect the first AOV to eval1, the second to eval2, the standard shader to pass-through, and finally the node itself to the beauty port. Also, the individual AOVs no longer require an active pass-through connection. And that was the final part of the setup. Now you can successfully preview custom AOVs in the IPR. In this lesson, we'll take a look at reading AOVs. We'll start by creating a custom pass representing the coffee labels. The ultimate goal here is to generate an additional color scheme based on the initial RGB values. So let's drag right RGB in, connect the raw color data to the input port and set a custom name, like labels for example. It is easy to predict that eventually we'll need to evaluate multiple AOVs at once, thus it is only logical to utilize a pass-through shader as well. So scroll down to Utility and drag pass-through in. Connect the AOV to eval1 and the standard shader to pass-through. Set up a matching AOV object, call it labels, confirm, and preview the effect in the IPR. With this layer in place, we'll use readRGB to access its data, apply changes to it, and finally export it as yet another AOV. So let's apply readRGB, and to read the content of a predefined output variable, we need to call it by name. So under AOV name, once again type labels. Next, apply color correct and offset the hue shift by 0.5. Now we need another write RGB, which will store the result as an additional AOV. Connect the color correct to the input, set a custom name like labels underscore offset, and connect the output to eval2. Set up the required matching AOV object, call it labels underscore offset, confirm, and preview the AOV in the IPR. Unfortunately, as you already see, read nodes are currently not compatible with the IPR. In other words, the output of such AOVs is only accessible via the picture viewer. So let's open that up. And similarly to the native multipass workflow, available AOVs are visible through the Layer tab. The effect of the color correct shader is now clearly visible in labels offset. What's interesting here is that if the initial values change, for example, we use a multiply to push the color of the labels towards green, for example, the respective AOVs will react accordingly. Additionally, it is worth mentioning that data brought in the network via an AOV read can easily interact with the rest of the shaders in the editor. For example, it can be used to define the diffuse color of the standard shader. Open up the picture viewer to preview the result.